All right, here we go. First calculus notes. Technically, I think the date on that would be 8/25, but and it's our first notes of the first quarter. So we're starting off with limits. And before we get into the notes there, I just have a little comment there. Letters of recommendation. Participate in class, stand out in a good way. A lot of students ask for letters of recommendation, and it's easier if you've participated in class and commented. I know it's a little bit harder in this format, but something to keep in mind. And so let's go ahead and get started. So as we talk about limits, a couple ways I like to describe it is a penny. How many of you pick up a penny when you see a penny on the ground? And then you would raise your hands and we'd see, and usually it's not very many people. So I talk about that as a limit. Basically, most of us treat a penny as zero. So 0.01 in money is so close to zero that most of us just treat it as zero. The next idea is if I wanted to go half the distance every minute or something like that. Let's say I was going to go 10 feet. So if I went half the distance, and normally I would do this like walking over to the classroom door, but so I'm going from here to here. Let's say that's 10 feet, and every minute I go half the distance. So the first minute I go 5 feet, and then I go 2.5 feet, and I keep going half the distance. But as I get super close to the end of that 10 feet, my distance becomes microscopic, like a millimeter. I know I'm switching from units there, but so eventually, if I ask you how far have I gone, you could say 9.999999999 feet. Eventually, most of us are just going to say, well, you've basically gone 10 feet. We've basically gone that distance. And so that's kind of what a limit is. And so here's how we write it out. The limit of a function as x approaches some number equals L. So the limit of a function, I just read that. All right. So if we want to look at this function here, and we want to find the limit of this as x approaches 2. Well, hopefully we all notice right away, anytime you have a rational function expression, you know that we don't want it to be dividing by 0. So we know that we don't want x to equal 2. That's going to be does not exist. Okay. So one way we can do this, we're going to focus on numerically and graphically today. So here's the TI 89 calculator, which you are able to check out for the entire year. And what I want to do is enter in a function. So I'm going to type the green and y equals, that's in the top left corner there. And I'm going to type in this function. So that's going to be x squared minus 3x. Sometimes the 89 gets a little bit particular. You might want to do 3 times x, but and then plus 2 divided by parentheses x minus 2. So x, y, and z have their own buttons here. Close parenthesis, enter. And that should look on the screen pretty much the same. And you can tell if you always want to check, make sure you typed it in correctly. So now what we can do is we can go to the table. And if we go to table set up here, usually it's in automatic. So a table will be generated, and you can change those values and do things. But what I want to do here is go back to table set, which is F4, the green button in F4, and I want to go down here and change the independent variable to ask. So I want it to ask me for values. So alright, I'm going to type in a couple values here. So 1.75, enter, move down, 1.9, enter, move down. So I'm just typing in the numbers on this chart here. 1.999, enter. And 2 I don't need to type in because 2 is going to be undefined. So 2.001, enter. And you can see it's giving us those values over on the side. So 2.1, enter, and 2.25, enter. So now we have those values and we can copy them from the calculator onto our table in our notes. So that's going to be 0.75, 0.9, 0.999, 1.001, 1.1, 1.25. So if we ask the question, what's the limit as x approaches 2, by looking at a chart, a table of values, we can see that on this side we're getting really close to 1, and on this side we're getting really close to 1. So the limit of this equals 1. Now, the fact that it doesn't exist, the function doesn't exist at x equals 2, that makes no difference because we're never actually going to reach 2. So since we're never going to get there, it doesn't really matter what's happening there. The question is about what's happening as we get really close to 2. And so the answer is just going to be 1 there. So we could do this next one with a table too. You could type that in to your y equals. I'm going to spare you that here. I just showed you how to do that once. So we want to know what's happening as x gets close to 0. So we could type in negative 0.001. We know here again that 0 is undefined. And then we can try something on the right side, so 0.001. So if we plug this into that function, we get negative 0.0005. And if we plug this in, we get 0.0005 positive. All right, now another way to do that would be we could graph it. So if we graph this function, so maybe I will type it in just so that we can see the graph of it. Now, for the calculators, we'll talk about some different things and get you used to them as we go. 1 minus cosine x, and that needs to be in parentheses because it's the numerator. So divided by x, enter. Now, on the 84s, you highlight the equal signs, I think. I haven't used an 84 in a long time to graph them or not. Here, use that check mark, F4. So I don't really want to graph that right now, so I'm going to hit F4. You'll notice that it removes the check mark here. Here, we still have a check mark. So now if we go to graph, yeah, my window is, I changed my window. So if that happens, you can just go to your window and hit F2 zoom. And 6 is zoom standard. That goes negative 10 to 10. So we could try that, see how that looks. That's not, well, I guess. I could change the window and get a little bit closer there. So we're wondering what's happening as 0. So maybe we'll do that. Zoom. You could zoom in, or you could change the window manually. So I'm going to do that. I'm going to change that to negative 2 to 2 and negative 2 to 2. Okay, so now we're zoomed in closer here. We can see as x gets really close to 0, both sides of this graph are approaching 0 for y. So as x approaches 0, y is approaching 0. So graphically, that looked something like this. But I should have put a hole there, an open circle. And you can't see that. So, all right. So the limit of this function as x approaches 0 is 0. All right. Now, when we highlight a question in our notes, that's we want to draw extra attention to those examples, and test questions, AP questions, That's what we want to focus our studies on. When you have assignments in the textbook, you want to focus on questions that are similar to the questions that have been highlighted in the notes. So sometimes in the assignments there'll be questions that aren't as important, as far as if you're struggling, you don't want to spend a lot of time unless the question is similar to something that was done in the notes. Okay? So this question